We'll use the same example as we did in the last video on backpropagation. So if you haven't watched it, please refer to it. In backpropagation step 2, we update W1, W2, W3, and W4. As before, the process is the same for each weight. So let's start with updating W1. So to update W1, we need to calculate the partial derivative of E total with respect to W1. And using the chain rule, we break this down into 3 parts. Now we can write the partial derivative of E total with respect to H1 equal to the partial derivative of EO1 with respect to H1 plus partial derivative of EO2 with respect to H1. So the partial derivative of EO1 with respect to H1 equals to partial derivative of EO1 with respect to Z3 multiplied by the partial derivative of Z3 multiplied with respect to H1, which is equal to partial derivative of EO1 with respect to O1 multiplied by partial derivative of O1 with respect to Z3 multiplied by partial derivative of Z3 multiplied by H1. So this is just the same as minus the actual value of O1 minus the output, the predicted value of O1 multiplied by O1 multiplied by 1 minus O1, which is the derivative of our activation function, sigmoid function, multiplied by W5. So this is 0.209 multiplied by 0.238 multiplied by 0.45, which is equal to 0.0224. Now, the partial derivative of E total with respect to O1 is equal to minus the actual value of O1 minus the predicted value of O1, which was minus 0.4 minus 0.609, which is 0.209. And the partial derivative of O1 respect to Z3 is equal to O1 multiplied by minus O1, which is the derivative of the activation function sigmoid, which is equal to 0.609 multiplied by 1 minus 0.609. So this is 0.238. And the partial derivative of Z3 with respect to this is equal to W5, so 0.45. And following the same step, we get the partial derivative of E total with respect to O2 as 0.0638, and the partial derivative of O2 with respect to Z4 as 0.223, and the partial derivative of Z4 with respect to H1 as W7, which is 0.7. So now we sum these partial derivatives to get the partial derivative of E total with respect to H1, which is 0.032. Then we calculate partial derivative of H1 with respect to Z1. So this is H1 times minus 1 minus H1. So this is 0.1599 multiplied by minus 0.199, which is 0.2496. Finally, the partial derivative of Z1 with respect to W1 is X1, which is 0.1. So multiplying all these together, we get the partial derivative of E total with respect to W1 as 0.0324 multiplied by 0.2496 multiplied by 0.1, which is 0.0008. W1 plus equals W1, the old W1 minus alpha, in our case, 0.5 multiplied by partial derivative of E total with respect to W1, which is 0.3 minus 0.5 multiplied by 0.0008, which is 0.2995. Now, we can apply the same process to calculate and update W2, W3, and W4. Now, these are the answers for W2, W3, W4. Try it on your own and compare with your answers. Next time, I'll explain the overall process of forward and backward propagation and the way to evaluate the overall process of the neural network. Thank you.